Hello, in this video I am going to demonstrate writing a solution to the kind of problem that you would have been assigned from this chapter of the textbook using JavaScript. So the idea with these videos is that I will put up a problem on the screen on the video, and hopefully you will pause the video and do your best to solve the problem. And then you can come back and press play and watch through the rest of the video to see how I solved it, to get help with any problems you ran into, and also to see if I solved it in maybe a different way than you did. Now, one thing to know about these videos is that I don't rehearse them ahead of time, and as I'm programming, I often do make all kinds of mistakes, including pretty silly mistakes, and I don't edit them out. Part of the point of this is for you to watch someone go through a problem so that you can see the kinds of issues that come up and you can hear me think through how I solve those issues. And sometimes that's useful for students who they kind of understand the code, but they don't necessarily know how to put it all together. So with that in mind, here is the problem that we're going to take a look at. Again, I would encourage you to pause the video at this point, do your best attempt at a solution, and then come back and watch how I solve it. All right, so I'm going to assume that you have taken a look at the problem and you have made your best effort to try and write code to solve it. And the purpose of the rest of this is for you to see how I go about solving it and kind of compare your way to mine. There's no reason that you can't do it differently and still get a valid solution. But it is good to see how other people work through it. And if you did get stuck, maybe watching me work through it will help you figure out what you did wrong. Now, what I'm going to start with is something that is sometimes hard to convince beginning programmers is valuable. I'm going to start out with this idea of test cases, and I'll save my big sort of lecture about test cases for later on in the course. But the idea here is before I write any code, I need to have a very clear sense of what this code needs to accomplish, what it needs to do. And so test cases are one way of addressing that. The idea of a test case is I'm going to come up with some numbers that I can put into my program, and then I'm going to figure out what the expected output should be. The alternative to this, and what a lot of students are tempted to do, is to just run your code. You type in, you make up some numbers off the top of your head, you type them in, you get some result back, and you say, well, I guess that looks good, and you turn it in. And often we can get away with that, especially if it's a very simple problem that we're trying to solve, a very simple program that we're writing. But as our programs become more complicated, it's difficult to tell if we've made a mistake, because maybe I divided when I meant to subtract or something like that. You get a number and, well, yeah, I guess that seems reasonable, but maybe it isn't the right answer. So I like to start out with test cases, and again, I'll go over test cases in some future video. And it doesn't even matter what they look like. The point is just to take a moment to figure out what this program should produce as results, and to give me some numbers to try when I'm testing it to see if it's working. So the idea here is I'm going to type in these three numbers, length, width, and height, and then what I'm going to get back from the program is the bottom area, the surface area of the bottom of the box, and then I'm going to get back the volume of the box, and then I'm going to get back the total surface area, the surface area of the entire box, not just the bottom. And so I like to say 3 is a good sort of round number for a set of test cases. The truth is, in real programming, sort of real life programming in industry, 3 is not nearly enough, but it's hard enough to get students to do any, so we'll start with 3. And I always say the first one can just be a real simple test case. And so if I just type in that the length of this box is 1, the width is 1, and the height is 1, what answers should I get? Part of what this is going to force me to do is figure out the math. I'm not a particularly strong math person. It turns out that I know these particular equations, but if I'm not, this is the point now when I get on Google and I go look up how do I calculate the surface area of a box or whatever. So so that's the other thing that we accomplish by doing our test cases first, is we get a clearer sense of what the program should do. The truth is that we can't program the computer to do something if we don't understand what we're asking it to do. So the area of one side, the bottom, is just the length times the width. Now, 1 times 1, of course, is 1. Okay? The volume of the entire box is the length times the width times the height. So that is also 1. 1 times 1 times 1 is still 1. The surface area is slightly more complicated. We have to do the area of each side and add them up. And so one way to look at this is it's the, one side is the length and width, one side is the width and height, and another side is the length and height. And that's only 3 of the 6 sides, right? So then we can multiply the whole thing times 2. So we can say 1 times 1 plus, that's 1, plus 1 times 1 plus 1 times 1, so that's 3, and we multiply the whole thing times 2, and that gives us 6. It turns out, because I'm not a math person, I jotted down these test cases while you guys were writing your code. So there's no magic to this. You just get out a calculator and you throw in the numbers. So the next test case I came up with is, what if we have 2 for all of these? And so a 2 by 2 box, a 2 by 2 by 2 box, the surface area of the bottom is 4, excuse me. Length times width is 4, 2 times 2. The volume, 2 times 2 times 2, is 8, and the surface area is 24. And then for my third test case, I wanted numbers that are a little more kind of realistic or complicated, however you want to look at it. So I just made them up. As I was typing in my calculator, I did length of 4, width of 7, height of 3, and so the bottom of that box is going to be 28 square, whatever units we're using, square inches, whatever. The volume is going to be 84, and the surface area is going to be 122. Okay, so again, that surface area calculation is the only one that maybe is weird to you. 4 times 7 plus 7 times 3 plus 4 times 3, and then all of that multiplied times 2. So we get 122 as our answer. And so now what I've done is I've forced myself, the non-math person, to learn these equations and to try them in a calculator. Hopefully I've done them correctly, since I did use the calculator. And when I get my code working, these are the numbers that I will type in so that I can see if my code works correctly. All right, so I'm ready to start working on the actual script itself. You can see that so that you wouldn't have to watch me type, I had set up basically a simple web page, and I'm ready now to begin adding my script onto it. So I'll make room here for my script. And one of the first benefits I get from my test cases is that I, as a programmer, have a convention that I use where I like to declare all my variables at the top of my script, at the top of my code. This is very individual. There are a lot of programmers who do this. There are also very many programmers who do not do this, especially JavaScript programmers tend to maybe not use this as much. But what I like to do is I like to have all my variables declared at the top of my script, if possible, so that I can glance at it and see everything that I'm going to be using all at once. And so the first thing I'm going to do is I'm going to look at my test cases and say, well, every input that I get from the user, that's a variable, right? So I'm going to have a variable called length. I also have this weird convention that I set them to default values that are sort of odd. So I set length to -1. And this is a conversation for another day. I don't need to get into it now, but it's a habit that I can't turn off. So if I don't mention it, you're going to wonder why I'm doing it. I just like to set them to a default value that is obviously incorrect, invalid data. So I'm going to have now the width. The other thing I like to do, incidentally, is make sure that my code is easy to read, and you should get in this habit no matter what. And there are two ways we do that. One is by choosing useful variable names, right? So length is a good variable name. X is much less useful as a variable name. We use it a lot in math class, and there are times in computer programming when X is a reasonable variable name. But generally, I like variable names that are descriptive, and that is not just me. That is, all programmers should believe that. The other thing I like to do, or I like to encourage, is if it's necessary, add a little comment next to your variable declaration that explains what it does. Now in this case, the length of the box, that's really silly and redundant because I've used a good variable name that is self-explanatory. So I don't actually need a code comment there to explain that. So that's another reason to use good variable names, so you don't have to comment all that stuff. So those three things that I get from the user, I have to store them someplace. So now I have three variables to store them, and we'll just ignore the fact that he put that weird -1 in them. Why did he do that for? So I can also see that I'm going to produce three different numbers as output, right? The bottom area, the volume, and the entire surface area. So that's three more variables, right? If I have to do calculations for those and store them, I will need variables eventually. And again, I like to declare my variables early on, up at the top of my script. And again, I'll give it a good variable name. You might not like the idea of having to type all of that, but it's clear then what that variable represents when I'm reading the code. So you'll hear us talk about code readability, and that's one of the things I grade on when I grade your assignments, is how readable your code is. So another thing someone might do is something like this, BA, and then over here say bottom area. Okay, so that's if you don't like all the typing in your variable name, you can do it that way. All right, bottom area equals -1 for, again, reasons that aren't that important. Volume equals -1. Now one thing, we're not going to run into it here, I don't believe, unless I stop thinking and make a mistake, but the variable names, there are all kinds of rules we have to follow. The book covers those, and sometimes we forget that there are words that have meaning in JavaScript. I can't use one of those words as my variable name, so I can't use var, for example, as a variable name. Okay, surface area equals -1. Okay, so I've declared all my variables. I can't stop myself. I have a lot of coding habits, having been a programmer for a long time. So I'm just going to sort of identify that section of my code as the variables. And then what I'm going to do next is I'm going to get the input. Okay, so I'll have some code there where I get input. And then I'm going to output my results. And this little template of these three sections will serve you well. There will come times when this is not necessarily the way you want to organize your code, but if you're a beginning programmer and you want sort of a recipe to follow or a template to follow, this is a good one for the moment. Is figure out what all your variables are going to be and declare those. Get whatever input you need to get from the user, and then and as part of that, then you're going to do your math, and then you're going to output your results. So there we go. Okay, so the first thing I need to do now is get some input from the user. So we've seen from the textbook that we can use this prompt function, prompt method, you'll hear me call it. And so what I can do is I can say, let's ask for the length first, and I can say length equals. Now, the convention in the book, it would be var length equals, but I've already declared it up here. So this is, again, individuals do things slightly differently. You don't have to do it my way, but if you do it my way, we don't declare it again. We don't put var again. Okay, I'm going to use the variable I've already declared. Equals prompt, enter the length of the box. Okay, and I won't provide any default. I'll just have the preset value be empty, and then we'll do the same thing for width and height. So you're probably tempted to copy and paste, and that's not the end of the world if you do. But I do always tell my students that you don't learn to code by copying and pasting over and over again. At some point you got to get used to writing the lines of code. It actually does make a difference. Another one of those things that's hard to convince students. Height of the box. I also can't type and talk very well at the same time, so sorry if I get distracted here. All right, now that's possibly it for getting the input. And certainly I don't like to write a lot of code without stopping to test it. So I am going to go ahead and save this, and now I want to run it. I use Firefox for mine. Okay, and so far so good. It's popping up and asking me for the length of the box. So I'm going to say that my first test case was 1, right? So maybe I want to use my third test case, I think, because I want to make sure that the values are getting stored in the right place, and if I put 1 for each of them, that's maybe confusing. So I'll use 4 and 7 and 3. And that's it. It's not particularly exciting at this point. I will take a look at the debugging console here just to see if there's anything we can tell from this that is interesting. I can just look at my code and sort of make sure that I don't have any obvious errors. I'll leave this on, and we'll kind of come back to this in a little bit here. But so far so good. That was really just a test to see if my code is working so far. We're not 100% sure it's working, but it seems to be. We're off to a good start. I was just about to move on, and I realized I can show something that is potentially useful to you with Firefox here. I am sure that that Chrome has the equivalent function here, but I don't know Chrome as well. I used Firefox. So in this set of tools we have for web development, notice I had said it seems to be working. We don't know for sure that it is working. It popped up 3 times and prompted me, and I typed in numbers, but I don't know what happened to those numbers. There is a tool here where we can see what happened, and so we can have what are called watch expressions, and I don't want to get too sidetracked on this, but this is really useful at this point. How do I know that it really took my length correctly and took the width correctly and took the height correctly? So I can add a watch expression, and I can type in the name of the variable that I want to watch, and it says length is equal to 4, and I can put in width, and I can put in height. Oops, height. And so I can see that it did take 4, 7, and 3, and it stored them in the right variables. What it is showing me here is what is the value of those variables. Now, it turns out I can already see that there's going to be a problem, but it may not be obvious yet what that is. It may not be obvious to you yet what that is. And so we might be back looking at that and seeing where we end up. Okay, so that's it for getting input. The next step is going to be to start making some calculations, and it doesn't actually matter if we put those under input or output. I suppose I said I was going to put them under input, but I suppose it makes more sense to do the calculations here, right? We'll do the calculations and then we'll write them back to the document so we can see them, or so the user can see them. And so we will start out with bottom area first, because I think that's a real simple calculation, right? I'm going to say this is what we call an assignment statement. And an assignment statement is anything that has an equal sign. And so I've already got a bunch of assignment statements in my script. But the way to look at this is two different parts. There's the part on the right of the equal sign, and there's the part on the left. And so on the right is the expression that is going to produce some value. And then on the left is where we are going to put that value. And so in these cases up here at the top, there's not really any math to do. I just said, well, take the number -1. And so where is it going to put that? It's going to put it into a new variable called length. And same with width and height and bottom area and volume and surface area. Down here, I say, well, go run this code that pops up and asks the user to type something in. Take that result and put it into length. Okay, and then the same thing for width and height. And now I'm going to do the same thing for bottom. Now bottom area, almost made a mistake there. Bottom area isn't input, it's a calculation. So I can write an arithmetic operation and make a calculation. And so the area of the bottom of a box is just the length times the width. And multiplication in JavaScript is the asterisk or the star symbol. length times width. All right, and so let's just stop there and see what happens. Let's just run it and see what we got. So I'm going to hit refresh. Notice I've still got my watch expressions there. Length of the box, I'll say, actually I'll go back to my easier test cases that I had set up before. Oh, my watch expressions need to be refreshed. Sorry about that, I forgot. So they have all been set equal to 1, because those are the 3 numbers I typed in. And now I've got maybe another watch expression that I want to know what the bottom area is. Bottom area is 1. So far so good. It sounds good. Okay, sounds good. Bottom area is 1. And what I wanted to point out before, I was holding off till it was a little more clear what the difference is. Notice the way the 1 is written here versus the way it's written up above. Okay, length, width, and height have quotation marks around them. Bottom area, it doesn't. This gets back to the idea of data types, where how is this data actually being stored by JavaScript. And so if it has quotation marks around it, it is actually a string. It's being stored as text. If it doesn't have quotation marks around it like this, that means it's being stored as a number. And JavaScript is often very good at converting it back and forth. And so what's happening in our code, this is nice here, we can see our code right there, is prompt actually gives us back a string. So it's putting a string into length, width, and height. But when I go to do this bottom area assignment, it sees length times width. That multiplication sign signals JavaScript, hey, we're talking about numbers. So we need to convert these values, length and width, into numbers and then multiply them. This is not correct, but if we make a change, and let's change that to addition, we have kind of a funny side effect. Oops, wrong refresh. So let's type in 1 and 1 and 1, and then let's refresh what we got here. It's interesting. Length, width, and height are the same. They are all strings. And now bottom area, instead of giving me an answer of 1, it has given me 1, 1. And it's a string instead of a number. The book does discuss this a little bit, but what's happening here is the fancy word for this is concatenation. It turns out the plus symbol in JavaScript can mean 2 completely different things. It can mean addition, take these 2 numbers and find the sum, but it can also mean take these 2 strings and put them together. Okay, that is called concatenation. So if it sees 2 strings with a plus sign between them, it does concatenation and it jams the strings together instead of doing addition. All right. So if we want to force it to do addition, we have to first convert these into numbers, and that's not part of our problem at the moment. The book shows you how to do that. You can we call it parsing. And so if I wanted to do addition with these 2 numbers, I would have to parse them into floats or integers first. And so again, that's not part of our problem at the moment, but it comes up. So I'll go back to that, length times width. And we seem to be in good shape. It said 1 for our solution, and that is what I expect. Let's try our more complicated test case here. Let's try 4 and 7 and 3, and if I look up here at my test cases, I can see that that should give me 28. Oh, and I accidentally collapsed my watch expressions there. So refresh that, and bottom area is 28. So we're in good shape so far. My bottom area calculation seems to be working, at least on those 2 test cases. So I will go ahead and continue on to the other calculations. So next up is, volume. Volume is length times width times height. Okay, length times width times height. So let's go ahead and try that as well. I'll go ahead and, before I forget, I'll go ahead and add that watch. Okay, volume is -1 because I haven't assigned anything else to it, and you kind of get a little hint, why did I set that to -1? So now if I see a -1 anywhere, I know that I forgot to change that value. I forgot to do a calculation. That's one of the reasons why. So let's do, we'll start with our simple test case again, 1, 1, 1. And then we will go to the top and refresh that. I'm going to need a little more room here. And indeed we get 1 for our volume, not the most useful test case. So let's try 2, 2, 2. And I'm expecting to see 4 for the bottom area and 8 for the volume. And then let's try our third test case, 4, 7, 3. And I'm expecting to see 28 for the bottom area and 84 for the volume, and sure enough that is what I get. So the test cases are proving helpful. I'm able to test and see that I'm doing it correctly. One thing I would point out here that you may notice or you may think to do yourself is length times width. So the idea of volume is that you're multiplying the bottom area times the height. Well, we've already calculated the bottom area, so one thing you could do, you can use that variable. I could write this same line of code like that. It turns out to be equivalent, and again, just a matter of preference. Maybe you like it that way. Maybe maybe it's more clear to you to have length times width times height. Either one is fine. And the last calculation we need to do is surface area, and this one is a little more complicated. So for the surface area, I have to get the area of each side of the box, of each set of dimensions, right? So I need to have length times width, okay, plus length times height plus width times height. I'm really hoping I'm not making a mistake here, because this is the kind of place where I make lots of mistakes. Now, the order of operation rules say that multiplication is going to happen first. So it's going to multiply length times width, it's going to multiply length times height, it's going to multiply width times height, and it's going to add all of those together. So parentheses here are not necessary, but they are certainly helpful. So just like in your math class, we can use parentheses to enforce order of operations that we want, and also to make it a little more readable. Okay. Now that's not quite the end here, but let's go ahead and test it and see what we've got so far. So I will go ahead and add one more watch. This is going to be surface area, I believe I called it. And we'll go ahead and refresh, and let's try 1 times 1 times 1. I'm expecting to see 6 for my surface area. And I didn't. I got 3. Well, that's weird. I'm going to try one more. I'm going to try my complicated one. 4 times 7 times 3. I'm expecting to see 122. And I'm not. I'm getting 61. What has happened is that I haven't implemented my formula correctly. I've calculated for 3 sides of the box. I've only done half of it, right? So now I have to take the whole thing and multiply it times 2. And what I'll do for that is use parentheses again to make it a little more clear, and to make sure that a little more clear to read, and also to make sure that the order of operations happens the way that I intend. Whether it's necessary or not is largely irrelevant. If it helps make it easier to read, it is worth it. So 1 times 1 times 1, we'll refresh and hopefully see 6. Okay. 2 times 2 times 2. I'll refresh and hopefully see 24. And my last test case right here, 4 times 7 times 3, and I'm hoping to see 122. So far, so good. This suggests, if I made reasonable test cases, this suggests that my code is working correctly. The catch here is that sometimes you don't make great test cases, and you may not have test cases that catch some of your flaws. But we seem to be on the right track. So we've got all of our input, we have calculated our results, we just need to now output them. So for now, we're going to use just simple document write statements here. I'm going to say bottom area plus bottom area. And here's an example, incidentally, of concatenation. It's not going to do addition with this string and that answer. It's going to concatenate them together. Document.write volume. Most of the time when I assign problems, incidentally, as I'm typing here, I don't care how pretty it looks. You don't have to make yours match mine exactly, in case you're worried about that. Sometimes in problems I do ask you to format it a certain way just for the practice, and you're certainly always welcome and encouraged to use your HTML and CSS skills to make your pages look nice. But don't lose sight of the fact that what we're really learning here is JavaScript. It's not a class about making really pretty CSS, you know, style sheets and things like that. So surface area. All right, so let's just go with that and see what we have now. Hopefully now, since we'll be getting output, the watch expressions won't be as important. But still sometimes useful in the debugging process. So bottom area 1, surface or volume 1, and surface area 6. That does match my test cases. Doesn't look very pretty, but we are on the right track. 4, 7, and 3. I skipped a test case. So 24, 84, 122. I better go back and do that center test case. You never know when you can accidentally change something that used to work. We call this regression testing. I'm still checking the things that worked before to make sure I haven't broken them. 4, 8, and 24. So this looks really good. And honestly, the fact that they're jammed together without any spaces is pretty ugly. But in terms of the script itself, I as a teacher have seen what I need to see from this in order to award the points, unless there's something in the rubric or the directions that says it needs to look really nice. So if that's all you needed to see, you could actually stop the video here and go on. What I'm going to do is take a couple minutes to pretty this up a little bit. I'm just going to show how we can use document write to output tags and HTML to make our output look the way that we want. It's nothing earth-shattering, but if you want to see me go through that process a little bit, you're welcome to watch. If all you care about is how to do the calculations and use the variables, you can safely stop watching at this point. All right, so I'm not going to get too carried away with how to do this because it's really about HTML. I just wanted to draw attention to the fact that you can output HTML as part of your document.write statement. Now it's going to turn out that later on, this isn't my favorite way to format and make our results look pretty. I think there are better ways to do this, but at this stage of the course, this is the most reasonable way, and it takes advantage of things you already know how to do. So let's say that I want to just have this be in like a little bulleted list. So what I can do is before my script starts running, it doesn't matter where, I can write all of it inside the output area, but I can do some of it up here just in HTML. I can go ahead and set up my unordered list. That's where it's going to start, and it's going to end somewhere down here, right? I could do whatever styling I want to do, either inline or up at the top or even in an external style sheet. And now when I output these, what I can do is I can include whatever tagging I need to include, if I can manage to type it. All right, so I'm going to write out a list item tag, then I'll write my results, and then I'll close off that list item tag. So again, it's not like this is anything particularly fancy, but it shows the concept. And I do sometimes ask in assignments to see you output some CSS or some HTML just to make it look somewhat nice. And it is a good chance to practice those skills and to get in the habit. You know, ultimately we want people using our web pages, right? So we want them to look nice and to be user friendly. So so let's see how that looks. Come back here and try it again. It doesn't particularly matter which test case I use for this one, and maybe at this point I would want to try some other things as well, some other numbers. But you can see that now it's formatted with that idea of a bulleted list, an unordered list. And one of the things I can do is I can drill down over here with my debugger here. I can look at the HTML file. Oops, I'm in the wrong spot here. I want the inspector. In the inspector, I can see all the elements and I can interact with them. I can see them highlighted. And for the unordered list, I have the results of my script, and so it doesn't really show those. But what you can do is you can expand that, and it'll show you what was actually written to the document. So you can troubleshoot if your list doesn't look right, or if your HTML didn't work the way you expected. You can troubleshoot that here in the inspector. I can also then see what the actual script was that produced it. But it's sometimes, we know what the script says, but for some reason it's not writing out what it's supposed to. You can also, of course, just right-click and say View Page Source, and you can see your script kind of handy that way. But if you want to see what actually got written to the document, the inspector in Firefox is one way to do that. All right, so that's it for this video. I just wanted to show the basics of how this would work. This is not the most impressive program in the world, but we're just learning how to use variables, and so we want to make sure we know how to create variables, how to put values in them, and then how to manipulate those values with math operations and then output them back to our web page. The only other thing maybe worth mentioning is that I didn't use the alert function, which pops up that pop-up box. You hate those as users. All users hate them. They should only be used for really super important things where you have to dominate the user's attention and force them to look at it. It backfires most of the time, it seems like, because we're all just sort of trained to, we just click OK to get rid of it. It's useful as a learning tool, because if you just want to see, if you don't set up watches or something like that, you just want to see what a variable value is, you can say alert and then put the variable in there and see what it is. But since we know how to use watch expressions, we might as well take advantage of that and use document.write to get our output back to the web page. So there we go.